All right. We are now going to look at industrial pollution. So here's just a graph that shows wastewaters by industry. So food is actually most of them. And then petroleum, followed by primary metals. So then he just gives some kind of crazy numbers here. Out of 66,000 drugs, pesticides, and other industrial chemicals, 70% of those had no toxicity data on them, and only 2% had a complete health hazard evaluation. And that's because there are just so many new pesticides and everything are created each year. Like we just haven't had time to really study them, which is kind of scary. And not just like pesticides, but like even medicines. So it's like, well, slow down in creating new things, but you don't want to stop that next new invention that could be like the cure for cancer either. Um, Let's see. So let's see, it's talking about heavy metals here. So this includes mercury, lead, cadmium, plutonium, and then some others. I think you hear most about mercury and like the biomagnification because of the fish. And so these heavy metals, your body can't get rid of them. So like the more you eat it, it just builds and builds and builds. Like you never flush it out of your system. And they're bad for you. I think mostly bad for like your neurological system, but probably bad for all sorts of other things too. And then they biomagnify, which is just that the larger predators have more in it because it's like each level of the food chain, like a little bit, or here, right here, a little bit, these eat it, it adds up even more in them. These eat those guys, adds up even more in them. Maybe then this eats this guy, even more in the puma here. So that biomagnification is up the food chain. So the larger predators have more of these heavy metals in them. Let's see, move my thing again. Oh, this just shows concentrations. So this is related to like here's Mount St. Helens eruption where this really spiked. This is mercury, a World War II manufacturing, um, all the way back to almost the 1700s. And then here is concentrations just in the United States. So seems like there's a lot in the western and then a little bit more in the northeastern areas. Oh, now this is really going to just list a whole bunch of other pollutants from industry. So these are inorganic pollutants, chlorine, acids, asbestos, some carbon-containing ones like herbicides, pesticides, insecticides, um, oil spills, and then these PCBs and MTBE, which I can't even remember now what those stand for. But those are some. They're bad. I want to say, are those the laundry services one? Mm, I don't know. Uh, Problems of control as efficiency of removal of pollution substances increase, the costs tend to skyrocket. Few systems clean it up to 100%. Sometimes the benefits of these compounds can outweigh the risk or cost. Um, Hold on, baby. I'm doing a recording. What, babe? Hold on. Let me see if I can pause. Okay. What? What are you talking about? What little things? Oh, for the not now, babe. I'm doing a recording. Leave it alone. I don't want you messing with that. Okay, baby. Okay, just put it on the table where I work for now, and I'll put it back later. And then go shut the door so I can finish my recording. Okay. Right. Thermal pollution is something really I hadn't thought about much before the book mentioning it. So these lakes and streams can become warmer or hotter than they really should be from using water, to cool our equipment and cooling generators and things, automobiles. And it sounds kind of harmless. Well, that's just temperature. But again, it comes back to the wildlife there. And, if these certain fish or critters, plants even, are adapted to living in a certain climate or at a certain temperature, when you mess with that, you're really harming the wildlife there. And then how do you clean that up? So dredging is where you remove the sediments, where everything is like fallen to the bottom of like the lake or stream. And so try to take those out. The problem with that though is that everything's settled. And now when you try to dig it out, you are stirring it back up. So how do you prevent those fine grained sediments and chemicals from just remixing with the water again? So it can be very expensive. Some of the things, maybe instead of cleaning it up, they just put down like a barrier, just put down like a plastic layer or something on top of it. You can also, for some of these chemicals, you can try to treat them or cause some kind of chemical reaction, put in a salt or something that's going to react with it, and it'll form into like a, precipitate out of solution kind of thing. Um, so that could be possible depending on what you're dealing with. Um, The active detoxic spills often require treatment to decontaminate water, animals, and sediments, artificial aeration. Oh, yeah, just adding oxygen. We talked about how oxygen helps clean up the water quite a bit. And then, oh, here's that simple fountain can help, add oxygen and prevent the eutrophication. And then next, we will be switching into groundwater pollution.